Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if you want to have such more solutions. Now I am going to solve this particular problem. In this problem we are required to determine the forces in all of these members, right, this given truss, and we will use the method of joints to solve this particular problem, right. So now we will start from this joint A, since at this joint A we have this one known force and two unknown forces, right. So normally or usually we need to start from that particular joint where we have at least one known force and two unknown forces, right. So now if we start with the joint A, so then if I draw the forces, right, so let's say that the member AB is applying the force on this joint A in this direction, that is towards the right, and let's say that this CA member or AC member is applying the force on joint A in this direction, right. So before going to analyze this, first we have to find these angles, right. We have to find this angle. Let's say that this angle is let's say theta, right. So as we can see that this ABC triangle, this BCD, all these triangles are similar triangles, right. So this means that if this is theta, so then this is also theta, right, and if this is theta, then this is also theta, right, and similarly this angle is also theta, right. So we need to find this theta first. So we can find this theta by applying tan theta. So if I apply tan theta to this ABC triangle, so as we can see that tan theta will be 4 divided by 3, right. So this will be 4 divided by 3 and theta will be equal to tan inverse 4 divided by 3. So let's find this, right. So tan inverse 4 divided by 3, so this is 53.13, right. So theta is equal to 53.13 degrees, right. So this angle is 53.13. Let me write it here. This is 53.13 degrees. And similarly the angle of this 130 pound force is given in the shape of this triangle, right. So let's say if you want to find the angle of this 130 pound with the horizontal, let's say if this angle is alpha, right. So then if we find this angle, so this angle alpha and this angle alpha will be same, since both of these angles are alternate angles, right. So then we are given this triangle, right. So this we can find this alpha by using this triangle. So this is 13, 12 and 5. So now again if we apply tan alpha, so tan alpha will be equal to 12 divided by 5 and alpha will be equal to tan inverse 12 divided by 5, right. So this is tan inverse 12 divided by 5. So this angle is 67.38, right. So alpha is 67.38 degrees, right. So now if I consider that joint A, right, so let me separate this, right. So this is our free body diagram for joint A, right. So let's say, let me write that this is joint A, this is that 130 pound force, this is the force of this members AC, right. So let's say that this is FAC and this is that FAB, right, and this alpha is known, this alpha is 67.38. let me write that this is 67.38, right. So now if this is our positive x and y direction, let's say, so then we can resolve these forces into its components, right. So now if I apply the equilibrium condition, that is the summation, let's say, let me write that at joint A we are analyzing joint A. So if I apply the summation of forces along y equals to 0, since this joint A is in equilibrium, since the whole truss is in equilibrium, so each joint is also in equilibrium, right. So we will apply the equilibrium conditions. So now to apply summation of forces along y, we have to resolve these forces into its components, right. So if I resolve this FAC into its components, so it will have one component which will be acting in this direction, it will have one component which will be acting in this direction, right. So if this angle is 53.13, so this angle is also 53.13. So this component is the cos component, right, and this one is the sine component. Similarly, if we resolve this 130 pound force into its components, so it will have one component like this and it will have one component which will be acting downward, right? So the summation of forces along y equals to 0. So this component is acting in the positive y direction, and this is the sine component of FAC. So I will write that FAC sine of 53.13, and this component is acting in the negative y direction, so I will write minus, and it is the sine component of 130, right? So I will write 130 sine of 67.38. So this will be equal to 0. So from this we can find FAC directly. So FAC from this equation will be equal to 130 sine of 67.38 divided by sine of 53.13. So this is 150, right? So FAC is 150 pounds, and as we can see that this FAC is acting towards the joint, so this means that this is the compressive force. As a reaction, this joint A will apply the opposite force on this AC member, right? So that force will compress this AC member, right? So if this force is acting towards the joint, so this means that this is the compressive force, right? And similarly, if we apply the summation of forces along x equals to 0, so now as we can see that this FAB is acting in the positive x direction, so I will write FAB. This component is acting in the negative x direction, and this is FAC cos component, so I will write minus FAC, and FAC is now known, which is 150. So 150 cos of 53.13. This is now known, this is 150, right, pounds. And similarly, this component, this is 130 cos of 67.38, and it is acting in the negative x direction, so I will write minus 130 cos of 67.38, and this is equal to 0. And we can write that FAB is equal to this thing, right? So FAB is 140, right? So FAB, this is 140 pounds, and FAB is acting away from the joint, so this means that this force is the tension force, right? So this force will elongate this AB member, right? And now if we consider joint B, let me consider joint B. Since FAB is acting away from joint A, so then it will be acting away from joint B as well, right? Since FAB force is the tension force, right? So it needs to be acting away from this joint B as well, right? And let's say that the force this BD member is applying the force at joint B in this direction, and let's say that this is the FBC force, right? So now if we apply the summation of forces along y-axis to joint B, if we apply the summation of forces along y equals to 0, right? So as we can see that only this FBC force is acting in the y direction, so this means that FBC is 0, right? FBC is equal to 0, and we can write that this is FBD and this is FAB, right? So if we apply the summation of forces along x equals to 0 at joint B, so as we can see that FBD is acting in the positive x direction, so I will write FBD, and FAB is acting in the negative x direction, so I will write minus FAB, and this is equal to 0. So from this we conclude that FBD equals to FAB, so FAB is 140 pounds, right? And as we can see that this FBD, it is acting away from that joint B, so this means that this is the tension force, right? So this means that the FBC force is 0 member force, right? So this means that we can neglect this force for further calculation, right? So we can assume that FBC force is no more here, it is not existing, right? So now if we consider this joint C, so we will only consider these 3 members for calculation, since the force in member BC is 0, that is a 0 member force. Since we know that FAC is a compressive force, so it will also compress this joint C, right? This is that same FAC force, right? And let's say that this is the FCD force, and let's say that this is FCE member force, right? So let's say this is FCE, right? So this is our free body diagram for and that joint C, right? So let me write that this is joint C. So at joint C, right? So now as we can see that this is that same theta which is 53.13. This is 53.13. So now again, if I apply the summation of forces along y equals to 0 at joint C, so now as we can see that we have to resolve this FAC member force. So this is that FAC, and its magnitude is known, right? Its magnitude is 150 pounds, right? So let me write that this is 150 now. This is 150 pound, right? So now if we resolve this 150 pound force into its components, right? So it will have one component which will be acting in this direction, and this is that this is 150 pound force is that FAC, right? So this is that angle theta which FAC is making. So this FAC will be making that same angle theta here, right? So this angle is theta, and this angle theta is 53.13, right? So we can write that this is 53.13, right? So this will be the cos component, right? And this FAC will have one component which will be acting vertically downward as well, like this, right? And similarly this FCD will have two components. It will have one component which will be acting like this, and it will have one component which will be acting in this direction, right? So if we are considering this angle, so then this is the sine component of FCD. So let me write that FCD sine of 53.13, it is acting in the positive y direction, and this component is acting in the negative y direction, and it is the sine component of FAC, and FAC is 150 pounds, right? So I can write that this is minus 150 sine of 53.13, and this is equal to 0, right? So if we divide this whole equation by sine of 53.13, so this will cancel out. So this means that FCD is also equal to 150 pounds, right? And since FCD is acting away from this joint C, so this means that this is the tension force, right? Similarly, if we apply the summation of forces along x equals to 0, so now as we can see that this component, this is the cos component of FCD, and now FCD is known, which is 150 pounds, right? So 150 cos of 53.13, this is acting in the positive x direction, and this is acting in the positive direction as well, right? And this is the cos component of FAC, so this is plus 150 cos of 53.13, and FCE is acting in the negative x direction, so I will write minus FCE, and this is equal to 0, or we can say that this whole term is equal to FCE. So this is 180. So this means that FCE member force is 180 pounds, and FCE is acting towards that joint C, so this means that this is the compressive force, right? Similarly, now if we consider this joint D, right? Since FBD force is the tension force, so it needs to be acting away from joint D as well, right? Similarly, this CD force is the tension force as well, so it needs to be acting away from joint D as well, like this. And let's assume that this member force is acting away as well, right? And let's say that this force is acting towards this joint D, right? So this is FDF, this is FBD, and whose magnitude is known. FBD is 140 pounds, right? So I will write that this is 140, and this is FCD, so FCD is 150 as well, this is 150, right? And this is FD, and this is FDF, right? So now let me separate this as a free body diagram. So this is for joint D, right? And this is that same theta which is 53.13, right? So now again, if we consider joint D, and if I apply the summation of forces along y equals to 0 at joint D, so then again we have to resolve these forces, right? So this 150 pound force will have two components, right? So it will have one component which will be acting in this direction, and it will have one component which will be acting like this, right? So now the summation of forces along y equals to 0. So this FDE is acting in the positive y direction, so I will write FDE, and this component is acting in the negative direction, so I will write minus, and this is the sine component of 150, right? So this is 150 sine of 53.13, and this is equal to 0. So this means that FDE is equal to 150 sine of 53.13. Now this is 150 sine of 53.13. So this is 120 pounds approximately. So FDE equals to 120 pounds. And since FDE is acting towards this joint D, so this is the compressive force. Similarly, if I apply the summation of forces along x equals to 0, so this FDF is acting in the positive x direction. So FDF minus this 140, and this component, this is the cos component of 150, right? So I will write minus 150 cos of theta. Theta is 53.13, and this will be equal to 0, right? So we can write that FDF is equal to this thing, right? So this sign will become positive. So this is 230. So FDF is 230 pounds approximately, and since FDF is acting away from this joint D, so this means that this is the tension force. Now we will consider this joint E for equilibrium, right? So as we know that the force in CE member is 180 pounds and it's compressive force, so it will compress this joint E as well, right? Similarly, FDE force is 120 pound force and it is compressive as well, right? So let's say that this is acting towards joint E as well, right? And let's assume that the force in this EF member is acting away from this joint E, like this. And since here we have this roller support, so this roller support will also apply a force in this direction, right? So let's say that this force is, since it is acting in the y direction, so let's say that this is EY, right? This one is let me write that this is FEF force, and the magnitude of this FCE force is 180 pounds, right? This is 180, so I will write that this is 180, and this force is this FDE force is 120 pounds, so I will write that this is 120, right? So this is 120 pounds, right? So if we consider the free body diagram for joint E, so we will have this diagram, right? And if this angle is theta, then FEF is also making angle theta here as well, right? So this angle is also theta, this angle is also theta, right? So now if I apply the summation of forces along x equals to 0, right, at joint E, this is joint E, right? This is that EY force. So is we can see that this EY force is unknown, right? So we cannot apply the summation of forces along y equals to 0, right? So we can only apply the summation of forces along x equals to 0, since this EY will not come in our equation if we apply the summation of forces along x equals to 0. So if I apply the summation of forces along x, so we have to resolve this FEF force into its components. So it will have one component in this direction, that is in the positive x direction, and this is the cos component. So we can write that this is FEF cos of theta, and theta is 53.13, and this 180 pound force is also acting in the positive direction, so I will write plus 180, and this is equal to 0. So now when we solve this, so FEF member force is, this is minus 300 pounds, right? So this means that the assumed direction of FEF is not accurate, it is acting in towards this joint E, right? So this means that if we assume the force in which is acting away from that joint E, so if the sign comes to be negative, so this means that this will be compressive force, right? So I would recommend you people that whenever you people are not sure about a particular member force, so then you people assume the force that need to be acting away from that joint E, right? So always assume the tension force, right? So if the sign comes negative, so then that negative sign will tell us that particular force is the compressive force, right? So now this negative sign tells us that FEF member force is 300 pound force, and this is the compressive force, right? So we have determined the forces in each member of this given truss. I hope you people would have understood this solution. If you people want me to solve more chapter 6 problem, so like this video for that.